Okay, I've got another WebGL in P5 video for you. And in this one, instead of drawing, oh, I erased everything on the whiteboard. That's fine, I don't need to go over there in my list. Instead of drawing a primitive shape like a cube, a sphere, a torus, a cone, etc., I am going to make my own shape with beginShape and endShape. So let's look at how that works. So this has a box with a kitten as the texture. When I'm done, I want to see just a custom shape also with the kitten as the texture. Let's see if we can make this work. Okay, so let's take out the box. Let's take out the texture just for now, and let's say normal material. Hopefully this is going to work. Now what I'm going to do is I'm just going to say beginShape and endShape. And I have another video tutorial just about how beginShape, endShape, and vertex works. And you can go refer to that one. Once you're into the 3D world, there's a lot of possibilities. We could tile with triangle strips and do all sorts of different things. But I'm going to just make a single shape that has vertices and is like basically like a quad. I'm going to make a quad. So I'm going to say vertex, just to start, 0, 0. Vertex 100, 0. Vertex 100, 100. Vertex 0, 100. And I think an important thing that I need to have here is close. So what am I doing? I have 0, 0, 100, 0, 100, 100, 0, 100. So this is my path. And all of a sudden now the close parameter in endShape makes the last vertex connect to the first vertex. Okay, so let's see. This is the equivalent of doing plane, right? This is like doing plane, but I'm doing it with beginShape and endShape. All right, I don't see anything. Let's try fill. There we go. All right, so normal material didn't work, but that's fine. Fill works. Can I get ambient material to work? No. So those seem like they might be bugs right now. I'll have to investigate those and come back to this video or write something in the description. But I really wanted to show you something about texturing. And first of all, let me just put fill back. The thing that I want to show you here that's important is once I have these custom vertices, I can start to really do weird things. Like, for example, what if this last vertex over here was a little bit more to the right? I now have this kind of quad that's not a standard square. And also, like, maybe I want it to sort of like center itself. So right now I could say just really quickly, I mean, I could redo all these vertices, but I'm just going to translate by like -50, 0. And so now I kind of have this quad moving around its center a bit more. So let me put this back. And we can see this is just like plane. -50, oh, I'm sorry, -50, -50 it should be. Okay, so now this is just like plane. Now what I want to do is texture this geometry. So what's interesting about this is let's just say I add right now texture, oops. I'm going to take texture kitten instead of fill. Interesting, so I don't see it. Why? Now something's happening, but I don't see the kitten. Why not? So this is what's really interesting about working with textures and custom shapes. A vertex is defined by its x, y point, or really in this case, x, y, z. That's what this is. This is really 0, 0, 0, 100, 0, 0, right? I just sort of ignoring the z, but I probably should put that in there. If I want to take image data, like a JPEG or a PNG or whatever, and basically place that image data inside of that polygon, the thing that I'm defining, I need to say, hey, 0, 0 goes with what pixel? This pixel. 100, 0 goes with what pixel? This pixel. Now this would be kind of like a literal mapping of saying like this image gets mapped exactly onto it. But what you're going to see about this is you can start to do a lot of different things. I will also refer you to a video about a flag simulation that I also have that does the same exact thing but with a more complex geometry. So for the vertex function, instead of just x, y, z, I can also have u, v. The U and V coordinates are the pixel mappings on the image. And I believe in P5 by default, these are normalized. So there are different ways this can be done, but what I mean by normalized is this is actually 0, 0, this is 1, 0, this is 1, 1, and this is 0, 1, even if this is a 640 by 480 image. So basically, so let's look at how that works. And let's start adding those UV coordinates in. So I think this should be, so let me add the 0 in, because I have a feeling it's probably not going to figure it out properly without the 0. So I'm going to now say this is 0, 0. This is 1, 0. This is 1, 1 UV. And this is 0, 1. So let's try that. There we go. There's the cat. Yay! On our custom shape. Now, it's so dark. Let's just pump up the ambient light here. All right, so I just wanted to add more ambient light so we could see it. Now here's the thing that's interesting. This mapping, you now have a lot of creative possibilities. Like for example, what if I just took out this point, right? What if I made this a triangle and kind of moved this point to 50, 50? So let's try that. So this vertex is actually going to be 50, 50. And we should see, look, and you can see how it's sort of trying to figure out as best as it can how to kind of squish the kitten. And probably in this case, just this rotation stuff is more trouble than it's worth. You can see this is what it's done, how it's decided to try to smush the kitten into that geometry. And this, of course, could move. Like I could say mouse X, mouse Y, which is going to produce a really weird result. But you can see this is me kind of like stretching. So you could imagine you could have an algorithm that's changing the geometry. I could have many, many more points. There's so many possibilities here. Another thing that I'd love to show, that I think is worth showing, is what if I reverse? So take a look at this kitten. See that kitten? It's looking that direction. What if I flip the pixels and say this pixel should go with 1, 0, and this should go with 0, 0. This should go with 0, 1, and this should go with 1, 1. Now the kitten's looking the other direction. What if I didn't flip the bottom? No kittens will be harmed during this. Like, now something weird, crazy happened because the top was flipped and I had to like twist it to get the bottom. So, and these can be variables, right? These could be variables that are changing and oscillating. I could, if I go all the way back, whoops. Let me get our kitten back there. I could do something like, I actually only want to see the top half of the kitten. So the Y are both 0.5. Now that's the top half stretched into this shape. So there's I'm really just scratching the surface here, but as you start to make your own shapes, you can texture them and assign different pixels of different images and different parts of an image to different vertices of that sounds of that shape. All right, so hopefully this was helpful. Hold on, my cap went running. There's still, again, as of the time of this recording, there seem to be some bugs with how custom shapes work in P5 WebGL. Hopefully any of you watching might decide to file a bug or look into fixing a bug in a friendly and supportive way. And hopefully, and please tag me at Schiffman on GitHub if you post an issue related to this video. Or of course, you can also ask at forum.processing.org in the p5.js category if you have kind of questions about how this stuff works. So thank you very much, and I look forward to seeing your custom geometry with textures in p5.js.